Hello teacher, this is my homework 3. Our subject is the quicksort algorithm. If we go back to my homework, we have a quicksort file. Our task is to compute the total number of comparisons used to sort the given input. In this file, we have a third rule. We implement the quicksort algorithm and compute the total number of comparisons for different pivot selection, the final element, maximum element, and random element. Our output have included these three elements. I passed my code in here, sorry, and then I add my quicksort text. Next, done. Okay, I run my code and what is the output? We will see. This takes a little time. Yes, our code is working correctly. If I want to explain this code, the quicksort algorithm is a divide and conquer sorting algorithm. We see this before the divide and conquer. We have a problem and we divide our main problem. Sorting algorithm that use a pivot element to partition to input array into two sub-array. The pivot element is chosen from the input array and it is used a reference point to divide array into the parts. Elements less than or equal to the pivot are placed into the left partition. Elements greater than the pivot are placed in the right partition. The pivot element is then placed in its final position in the array, which is the middle element between the left and right partition. The algorithm then recursively sorts the left and right partition, which are now smaller subarray. This process is repeated until the entire array is sorted. The case step is the algorithm is the partition step. This step can be implemented in the different way, and it is the main factor that determines the efficiency of the algorithm. In this implementation, there are three pivot selection methods. This implementation uses an iterative approach to avoid recursion error. It uses a stack to keep track of the subarray that still need to be sorted. The stack is initialized with the full array, and each iteration the top element of the stack is put and partitioned. The partition function works the same as the previous version. The left and right partition of the subarray are then pushed into the stack to be sorted in the next iteration. This approach eliminates the recursion and prevents the maximum recursion depth from being exceeded. This is our code, the main function that performs the quicksort algorithm. Initialize a variable to keep track of number of comparison. Helper function to partition of the array. Add the number of elements in the subarray to the comparison count. This is the pivot selection. Use the maximum element of array as the pivot, and then random elements. Partition the array. Use an iterative approach. Check if low index is less than high index. If yes partition, we use this. Push the left partition to stack, and then push the right partition to stack. Test the function with the input file. compare the function of comparison for different pivot selection method, and then finally print the result. Our result is this, and then our code is working correctly. Okay, if we go back to the homework, what is next? Okay, I think this is enough explanation and code. We have comments, we have comment line, and okay.